Okay, friends, I will start with discussion on iris flower data. In data science, whenever you start learning data science, data analytics, machine learning. This is one of the interesting and important data that one should go through. Iris flower data. You know the iris flowers. This is the slide which I am showing. Three types of iris flowers. This is one iris virginica. This is another iris setosa. This is third one iris versicolor. There might be many species of iris flower, but in the present data we are given the data of three species. From each species 50 flowers are collected. That means totally 150 flowers. And species wise four measurements are measured. Number one, sepal length. Number two, sepal width. Number three, petal length. Number four, petal width. And fifth feature is species. So like this, species either virginica, setosa or versicolor, its a sepal length, corresponding sepal width, corresponding petal length and corresponding petal width. So this is a 5-dimensional data of 150 points. Now when you are going to study this data, one of the most important suggestion for you the learners is that you first try to understand what is the importance of iris flower in botany as such and in overall life of human. What is the importance of iris flower? How many different species of iris flowers are there? And many more information about iris flower, and with respect to their species you try to collect it. Then you will come to know that why this data is particularly selected for the study purpose. You must understand and you must try to get the information. What do you mean by sepal? What do you mean by petal? What is the difference between sepal and petal? So like this, try to get some information about taxonomy of the flower and taxonomy of different species. That will help you in making the decision, in writing the conclusion. So this is the slide which I am showing you the pictures of these three species. Now I will show you the data on iris flowers. So let us see here. I will show you the data on iris flowers. Let us wait for data. Okay. So see, this is the data which I am going to show you here. Try to see this data. So let us see. Let us see this. See this data on iris flower. In fact, this is sepal length. This is sepal width. This is petal length. And this is petal width. Petal width. These are the species you can see here. Now, the problem is I have this 150 data points. I have information about 150 flowers. And now my question is, if I have another flower, say for example 4.9, petal length 4.9, petal width 3.2, sepal length 2.0, and petal width 0.8. I want to answer what is the possible species of this flower. See this. This is what we have to answer. This is another flower, 151st flower with sepal length 4.9, sepal width 3.2, petal length 2, and petal width 0.8. Question is, to which species does this flower belongs? Now, taxonomists, they can answer this. Taxonomists can use their taxonomy base and they will classify this flower in one of the three species. Now, is there any scope for statistics to classify this flower? And answer to this is yes. We can make use of our statistical knowledge, our statistical information, statistical modeling, and we can classify this. Okay. Now before classification, we will try to see the graphs of this. We will try to see the graphs of this. And so, first of all, let me sort this data. So I am sorting this data on the basis of species. So this is the sorted data. This is the sorted data. And now see, this is all data about Iris.Xls. I will take sepal length and sepal width and I will try to plot the graph. So let us see, this is the plot about Iris.Xls and I will insert a scatter plot. See this. This is about Iris.Xls. You can see this. Now I will extend my data still further and I will take into account all the three species. So once I take all these three species and I will insert the scatter diagram once again, you will see that this is the scatter plot. This is the scatter plot. Now this scatter plot will tell you that this is a data corresponding to one species. Clear-cut distinction is there. But this data corresponds to two species. And so it's a quite mixture. They are well mixed with each other. And that is why you will see how the problem of classification is serious. Here, problem of classification is quite serious. And so, taxonomists will also feel something confusing. And now if we give some strong base to his classification with the help of statistics, I think that will be more useful. I will take this data on Minitab and we'll see three-dimensional plot. Okay, so let us see all these data. I will carry on to Minitab. I think you can see very well the what is called as Minitab worksheet. Now I will copy the data here, and after copying this data I will try to plot 3D plot. So let us see this 3D plot. Now in this 3D plot I will take petal length on Z axis, sepal width on Y axis, sepal length on X axis, and I will plot it. See here. Here again you will see that one data set shows clear-cut distinction from other two, whereas other two data sets are quite mixed with each other, and therefore classifying the flower among these two is rather challenging than this. Let me take another plot. So for example, instead of sepal length, now I will take petal width here. And let us see the graph. You will see once again the same thing. You will see once again the same thing. Two species have near about same features. Another species have distinct features. That is what you can conclude from this. Let me plot another way also, 3D plot. Let me take here on Z axis, let me take petal width. Here let me take petal width. Now here I will take say sepal width and sepal length here. And see. Once again you will see, means I am taking all possible combinations, and all these possible combinations suggest me that one data set is quite distinct from the other two, and the other two species have quite similarly resembling features with respect to sepal length and petal length, sepal width and petal width. So that is why the problem of classification in this case is more serious. Now I will switch over this. I will cancel this, and now you can see that how to do this classification. How to do this classification. And therefore I will again come back to Excel. I will come back to Excel and will show you something. See here, it's a actual theory we'll see later on, but you can see here Naive Bayes Classifier. You can see here K nearest neighborhood method. So these are the two different approaches, and these two different approaches will give you some idea about the classification. Okay. Now let me come to Naive Bayes Classifier. Naive Bayes Classifier. It's a theory we'll see later on, but see how this works. In Iris setosa there are 43 flowers. In Iris versicolor there are 40 flowers. In Iris virginica there are 42 flowers. In all it's 125 flowers. You will ask me the question, why not 150? And the answer is very simple, that I am using this much data as a training type of data, and rest 25 set of observations means a data I will use as a test type of data. That means what? I will develop a classification algorithm based on these 125 observations. I will apply this algorithm. I will see what's the accuracy of this algorithm, and then I will implement this algorithm to test type of data. Once again I will see what is the accuracy of the overall situation, and then I will conclude whether I am doing good or it needs certain kind of what you call modification. Okay, I have done this in Excel stat software. XL stat, EXLSTAT, Excel stat software. This is the software which one has to purchase it, but it is a very interesting software. You can download it for a trial version, and you can use this trial version for the basic understanding. Now see here, this distribution, this Excel stat have number of applications, number of features, and number of application tools. That includes Naive Bayes classifier. Now if you see this Naive Bayes classifier, it's a distribution of quantitative variable is normal. So you are taking into account the normal distribution. I told you, whenever you are using distribution, that algorithm comes under supervised learning. So naturally this Naive Bayes classifier as a classification algorithm is supervised learning. How to break ties? It's a random one. Prior distribution is empirical one. Size of the training data set is 125, size of the prediction data set is 25. Now see here, summary is given. It's about the percentage of data. I will not go in that detail. Let us say this is another summary. This is a very important summary. This is the summary of sepal length, sepal width, petal width. All together, you will find what is the minimum sepal length, what is the maximum sepal length, what is the average sepal length, what is the standard deviation of sepal length. Similarly, sepal width, petal length, and petal width too. This is regarding the training data set. The same calculations are available for the prediction data set. See this. And now, this is the classification. Confusion matrix, it's a classification. Your Naive Bayes classifier has done the classification. It's a theory, it's a mathematical formulation, it's a decision making process that we will see later on. Let us try to understand, let us try to see the interesting part of this algorithm. So this Naive Bayes classifier, using certain prior information, have made the classification. How is this classification? See here, all the 43 observations, hey, this classification has classified in the same species. If you come here, out of 40 flowers, out of 40 observations from versicolor are classified only 38 in the same category. There are 2 flowers, those are Iris versicolor, but they are classified in Iris virginica. Among the Iris virginica, out of the 42 flowers, 3 flowers are classified as Iris versicolor, and 39 flowers are classified as Iris virginica, means in the same species. Now you will see that such a kind of misclassification is in versicolor and virginica only. It is not in setosa. Its reason is, very well we have identified in the graphs that one species is quite distinct from other two, and other two species are quite mixed with each other. That is why you will see this situation. Now, if you see the prediction set, you will find among the 25 observations, among the 25 what you call as data points, flowers, you will see this is the classification that flower 2, observation 2, observation 10, 17, 18, 20, 23, 25, they belongs to Iris setosa species. Third, 7th, 9th, 11th, 12th, 13th, 14th, 19th, 22 and 24. These observation belongs to versicolor. First observation, 4th, 5th, 6th, 8th, 12th, 16th and 21st, it belongs to Iris virginica. So among the 25, 7 belongs to Iris setosa, 10 belongs to Iris versicolor and 8 belongs to Iris virginica. This is the overall classification matrix, confusion matrix. This is the actual classification of an atom. You can see here. This is the prediction table, observation and it's a class. Observation and class. You will see this another posterior probability. Observation 1, it's 100% it belongs to virginica. Observation 2 means flower 2, it 100% belongs to setosa. You will see some probabilities. For example, here observation 6 belongs to virginica with probability 0.92. So it's a 92% chance that this flower is virginica, whereas there is a 8% chance that it can be versicolor. But majority carries the classification. Being 92% is a very high probability, the algorithm has classified this observation in virginica. You can see there are other also. See for example here, observation number 14. 44.5% chance that observation 14 will belongs to virginica and 55.5% chance that observation 14 will belongs to versicolor. Now here confusion matrix will play the role. Confusion is quite obvious because the probabilities are quite similar to each other or they are quite close to each other. If you come to observation 22, 1% chance that it belongs to virginica and 99.9% chance that it belongs to versicolor, it means this observation 22 has very high probability that it will belong to versicolor. So this is how the Naive Bayes classifier had made the classification. If you see the accuracy level, you will find 96% accuracy is generated by this algorithm. So this is a one algorithm, Naive Bayes classifier, and it is readily available in the software Excel stack. So friends, I tried to explain you this, and I hope this illustration had made you little bit simple. So if you have any question, you can put me an email and I will try to answer your question. Thank you.